So this is the 6th grade chapter 10 test review. I'm going to go through each of the problems, so follow along with me. The table shows the number of hours Felicia spent sleeping each night for 12 nights. Use the table for exercises 1 through 4. So they're talking about this table here. The first question is, what is the mean of the data? So remember, another word for mean is average, and to find the average, what I want to do is add up all of these numbers and then divide by the number of numbers I added. So I'm going to just add this direction. 8 plus 10 is 18, plus 6 is 24. 6 plus 8 is 14, plus 8 is 22. 7 plus 8 is 15, plus 8 is 23. 8 plus 6 is 14, plus 7 is 21. And so now if I add all these up, 4 plus 2 is 6, plus 3 is 9, plus 1 is 10, carry my 1. 1 plus 2 is 3, 4, 5, 6, 7, 8, 9. So the total of all of these numbers is 90. And then if I add these up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, then I need to divide 12 into 90. So 12 will go into 90, let's see, 7 times. 7 times 12 is 84. So 10 minus 4 is 6. So I'm going to add a decimal and bring down my 0. 12 will go into 65 times, so that will be 7.5. So the average or the mean of the numbers is 7.5. The next question is, what is the median of the data? And so remember, another word for median is the middle. So before I want to find the middle of the numbers, remember I have to order these numbers. So I'm going to start with the smallest numbers, which is 6, and there are 1, 2, 3 6s, so I need to make sure I list all of those. And then I have, let's see, 2 7s, and then there are 1, 2, 3, 4, 5, 6 8s, 1, 2, 3, 4, 5, 6 8s, and then last of all I have a 10. So I'm just going to count those up to double check I didn't forget anything. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have all of my numbers. And the middle numbers, I'm going to find by starting on the outside and working my way in. So I'm going to first and the last, first, last, first and last, first and last, first, last. So I can see that there are actually 2 numbers in the middle. And when that happens, what I want to do is divide those middle 2 numbers and then add those middle 2 numbers and then divide by 2 because I'm adding 2 numbers. So I'm really finding the average of these 2 numbers or the middle of these 2 numbers. If I add 8 plus 8, I get 16, and then if I divide by 2, I get 8, which is going to happen if these 2 numbers are the same, then the median is going to end up being the same number. So the median here is 8. The next question, number 3, is what is the range of the data? So the range is found by subtracting the high minus the low. So I'm going to take the highest number, which is 10, and the lowest number, which is 6, and I'm going to subtract those to get 4. Which measure of center best represents the data? All right, so this, I have 4 measures of center, so the mean, the median, the mode, and the range. And then we've talked about this in class before, but when the graph is not symmetric, then the best measure of center is going to be the median. When it is symmetric, and the best measure is going to be the mean. So here I can tell that on my on the low end I have 3 6s, and on the high end I have 1 10. So I know that there are 3 low numbers and 1 high number. That's not going to be a symmetric graph. So this is going to be non-symmetric. So the best measure of center will be the median. If we continue, refer to the dot plot for exercises 5 through 9. So over here we're going to be looking at the information we gather from the dot plot. Again, they're asking for the mean, the average. So I need to add up all these numbers. In order to do that, remember each dot counts as one of your numbers. So before I do that, I'm going to go ahead and list my numbers in order because I'm going to have to do that later anyway, and maybe that'll help me with the mean as well. All right, so I've got 1, 2, 3, 5. So 1, 2, 3 5s. I've got 2 6s because there are 2 dots above the 6. A 7. 1, 2, 3, 4, 5. 5 8s. 1, 2, 3, 4, 5 8s. I've got 4 9s. 1, 2, 3, 4 9s. A 10. 2 11s. And a 12. All right. So I need to add up all of these numbers. One way I can do that is by adding each of the numbers separately. So I've got 3 5s here, that's 15. I've got 2 6s, that would be 12, plus 7 would be 19. I'm just going to add a few at a time. So 1, 2, 3, 4, 5 8s. 5 times 8 is 40. I've got 4 9s here. 4 times 9 is 36. I've got a 10 and 2 11s. So 2 11s would be 22 plus 10 would be 32, and then I have the 12. All right, so it's a little simpler than trying to add up all these numbers at the same time. So I just broke it into pieces, and now I'm going to finish adding. 5 plus 9 is 14, plus 6 is 20, 22, 24. Carry your 2. 2 plus 1 is 3. 4 plus 4 is 8. 8 plus 3 is 11. 11 plus 3 is 14. Plus 1 is 15. So 154. And remember, I have to count all these up when I'm finding the mean. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So I'm going to divide 19 into 154. And that should go about 8 times. 8 times 9 is 72. Carry your 7. 8 times 1 is 8. Plus 7 is 15. So when I subtract, that's going to give me 2. If I bring down the decimal and a 0, oops, a 0 here, then 19 will go into 21 time. Subtract, I get 1. If I bring down another 0, I can say 19 is going to go into 10 0 times. I'm going to go ahead and stop and round to my nearest tenth. So I'm going to say that the mean of the data is 8.1. All right, and then the mode. Remember, mode is the most often, not the most. So sometimes people confuse the mode with the highest number, and it's actually the number that's used the most frequently. So if I look at all my numbers, and on a dot graph, that's easy. It's usually the highest, it is the highest column, or the highest amount of dots, which would be 8. Median is the middle number, so I need to find the middle of this group of numbers. We've got high and low, high and low, and low, high and low, high and low, high and low, high and, oops, low, high and low, high and low, and then the middle one would be right there, 8. Okay, so the median is 8. Is the dot plot symmetric? So remember, symmetric means when the left and the right side are mirror images of the other. And I know the median's right here in the 8. So if I look on either side of 8, I can see that these sides are different. There's 4 here, there's 1 here. That's not a mirror image, so no. They didn't ask me this question here, but since it's not symmetric, again, I'm going to use the median if they ask what's the best measure of center. 9 asks if there are any gaps in the dot plot, and you can see that there is a value for each of the dots. So no, there's not going to be any gaps. A gap would be like if there was no 7 there, then I could call 7 a gap. Remember, the mode is also could be called the peak. It's just a different way to ask the same question. All right, number 10. The data below shows the daily tips of a waiter in dollars. Represent the data in a stem and leaf plot. Best practice on these is to go ahead and start by listing them in order, least to greatest. So that's how I'm going to start this one. So my smallest value is 97. And then looks like 119 and 120. And I'm underlining mine because I try not to mark them out in case I make a mistake and need to read the numbers again. So I've got another 120, 122. 124, 125. Looks like I've got 132 3 times. And then a 135. And then 140. And 2 141s. And 2 142s. And then a 147. All right, so with the stem and leaf plot, I need to decide what numbers to use as the stem. Normally the leaves are just 1 digit, so I can, if I look at the first number, 97, the last digit is a 7. I know that's going to be my leaf, so my stem's going to have to be the 9. And there's only one number in the 90s, so the next stem I need to use is 11. So, and it has a leaf of 9. Again, there's nothing else that's 100 and or that would use a stem of 11. So I'm going to switch to 12. And then the digits that come after the 12 would be 0, 2 zeros, a 2, a 4, and a 5. Right, so I've got all my 120s. Now I'm going to switch to my 130, so that's a new stem. Got 3 2s, a 5, 135. And then the last stem is going to be 14. So I've got a 0, 2 1s, 2 2s, and a 7. All right, 11 says, what are using the stem and leaf plot in the above problem, in which interval do the most tips occur? So the most numbers that I have here are right here. I can see that this group has the most, so it's in my 140s. So I'm going to list that as 140 to 149 because that would be the complete interval. On 12, it asks me, Jabez surveyed people about their favorite sports. The results are shown in the table. Which type of display should Jabez use to show the results? So if I look at the information I'm given here, I can see that they've classified this by categories. So basketball has 25, and then football, golf, and volleyball. So normally when you're using categories, the bar graph is going to be your best choice of graphs. We keep going. 13 says the table shows the number of students enrolled at Tippett Middle School over the last 4 years. Which type of graph would best display the data? So I have 4 years here and a number of that goes with that. And anytime I'm using data that's been collected that's going to show a change over time, so this 4 year right here is kind of your clue, you want to use a line graph. 14, the table shows the favorite subject of students. Represent the data in a bar graph. All right, so there's nothing to find here. A bar graph, remember, is different than a histogram. A histogram uses intervals down here in the horizontal axis. This one just uses categories. Bar graph uses bars that aren't touching, whereas a histograph would. So I'm going to make sure to keep my bars separate. So mathematics, I'm just going to go from 0 up to 24. For science, I'm going to go to 12. English would be to 8. History is to 9, so that's a little above 8. Geography is 15, that's almost to 16. And economics is 17, so a little bit above 16. All right, and then if I had a pencil, I could go back and shade these. I'm just going to give them a little color so that they show up for the person reading their graph. 15, what is the relative frequency of economics? So it's important to remember when they're asking you about relative frequency, they're really asking you to find the percent. So I want to find the percent of economics. Remember, percent is a ratio of part to whole. So if I look back at economics, I can see that 17 is the part, but the whole would be how it compares to the total number of students. So that's what I need to find first. So first I'm going to have to add up all these. So 4 plus 2 is 6, plus 8 is 14, plus 9 is 23, plus 5 is 28, plus 7 is 35, carry your 3. 3 plus 2 is 5, and then 6, 7, 8, so 85. Okay, again, that's just the whole, the total. So now I have to make that a fraction or a ratio. So I'm really trying to figure out what 17 over 85 is, but as a percent. So remember, to do that, I'm using FDP. So my first step is to change it to a decimal, which I'm going to do by dividing or using Taibo. So top and bottom out, I'm dividing 85 into 17. Of course, I can't do that. So I'm going to add a decimal and a 0. 85 will go into 170 twice. 2 times, 10, 170. So as a decimal, this is 0.2, but I still need to keep going and make it into a percent. Remember, I do that by moving my decimal place 2 places. So if I move this over 2 places, I'm going to need to add a 0 here. So this ends up being 20%. So the relative frequency of economics would be 20%. For exercises 16 through 21, use the following set of data. So I have a list of numbers here, and then the first question they asked me is for the median. So again, anytime I'm looking for a median, I need to start by listing my numbers in order least to greatest. So it looks like 2 is the smallest, then 3, and 4, let's see, are 2 6s. There's a 7, 8, a 10, 11, 13, 15, and 24. Okay, so the middle number is going to be found by starting in the outside and working my way towards the center. So first and last, first and last. And I can see that there are actually 2 numbers in the center. So when that happens, the median is found by adding these up. So 7 plus 8 is 15, and then dividing by 2. So if I go ahead and divide by 2, 2 will go into 15 7 times. It's 14. When I subtract, I get 1, add my decimal and a 0, bring it down. So 2 will go into 10 5 times. So that means my median is going to end up being 7.5, which is right in between 7 and 8 here. That's 17 asks for the first and third quartiles of the data, so that's really Q1. We call that Q1 and Q3. That's found by finding the median of the first and the second half. So, and this is sometimes confusing to people, but I've divided my my data into half here with the median, and so I can see that there are now 6 numbers on this side and 6 numbers on this side. So Q1 is going to be the middle of these 6 numbers. So again, I'm going to have first and last, first and left. I'm going to have another set of 2 numbers in the middle. So I have to do the same thing I did right here. I have to add these up. 4 plus 6 is 10, and then divide by 2. So 2, when I divide into 10 is 5, so Q1 is going to be 5. So that Q1 is like right here. And then I do the same thing on the second half to find Q3. So I'm including 8 because 8 wasn't part of the median. So, or the median is ahead of the 8. So 8 is part of this data here. So I'm going to work my way in until I get to these 2 middle numbers here, 11 and 13. So again, I have to add these up. 11 plus 13 is 24, and then divide by 2. That gives me 12. So Q3, or the third quartile, is 12. And remember, they might also call this the lower and upper quartiles, but same thing. Okay, they're just asking about Q1 and Q3. 18 says, what is the interquartile range of the data? That's the IQR. And the IQR is found by subtracting the Q3 and Q1. So using these numbers I got in question 17, and I'm going to subtract 12 minus 5 is 7. All right, what are the minimum and maximum of the data? Okay, they're really just talking about the low and the high numbers here. So I'm going to look back at my numbers in order. I can see that the low number was 2. So the minimum is 2, and the maximum is 24. All right, and last of all, are there any outliers in the data set? So if I compare the numbers, the high and the low, to the median, here 2, when I compare it to 7.5, that's about 5 away, so that's not too far. If I compare 24 to the median, which is about 7, 24 minus 7, so let's just do it because sometimes that's hard to do. So if the median I said was 7.5. So if I subtract 2 from 7.5, remember to add a decimal and a 0, then I get 5.5. If I subtract 24 and 7.5, I'm going to get 3. Let's see. 13. So this would be 16.5. Okay, so I can see that 24 is actually much farther away from 7.5 than 2 was. So, and 24 is all by itself. Remember, an outlier, this is kind of a hard one, but outliers are all by themselves. They stand alone, and they kind of stand out as being much different than the numbers in the data set. So I would say that 24 is much larger than the rest of the numbers. 2 is pretty close to 3, so not an outlier. So yes, 24. And it's because it's much further from 7.5, or from the median, than 2 is. All right, the problem 21 says to draw a box plot for the data. All right, so that's the information that I just got up here. A box plot has 5 points that I want to put on the graph. So the first point I'm going to use is the median. That would be close to 8, but not quite all the way. Q1 is 5, so between 4 and 6. Q3 is 12. The minimum is 2, and the maximum is 24. So the value I didn't use is the IQR, and I don't need it. It's often they ask you for this value when you have to find Q3 and Q1, but it is not one of the values you put on the box plot. You're just going to use the 5 that we used. All right, so then I can draw my whiskers. Remember, a box plot is also called a box and whisker. And then I use Q1 and Q3 to draw the box, and then the last thing I do is draw a line through the median. So that's my box and whisker plot or box plot. And then again, I can see that this is not symmetric, and that's because of this outlier here. The 24 is much further away from the median than 2 was. All right. Oh, and the next question is the histogram symmetric? So that's talking about this one over here. So actually, I can see the middle part is right here. These are the same. These are the same. So yes, this is symmetric. How many people pledged $10 or more dollars? So be careful on that one. 10 or more starts here, but it also includes these values here. So it looks like there were 3 people here, 1 person between 15 and 19, and 2 people here. So if I add those up, 3 plus 1 is 4, plus 2 would be 6. 24 asks me which interval has the least number of pledges. Well, there's actually 2 of them, so I'm going to list both of them. So 5 through 9 has 1 person, and so does 15 through 19. 25. Which statement about the data represented by the box and whisker plot is not true? So the median is 30. So the median is this middle number, and the median is 30, so that is true. The interquartile range is 40. So remember, that is Q3 minus Q1. Q3 is 50. Q1 looks like it would be between 10 and 20, so minus 15. So 50 minus 15 is 35. That does not look right to me, but we're going to keep going just to check it out. There's an outlier at 110. That right here is your outlier, so I would say yes, that's an outlier. It's much further away from here than this number right here would be. D says the data in the 3rd quartile. That would be, so remember, the box plot divides your data into 4 groups. So here's first, second, this is your 3rd quartile, and then this part would be the 4th. The 3rd quartile is more spread out than the data in the 4th. So that would be true because this is a longer box than this whisker here. So also true. So yes, B is incorrect. It's not true because 50 minus 15 is 35, not 40. 25. Using the percent bar graph on the right, what percent of John's card collection are hockey cards? So unfortunately, this did not copy like it should have, but baseball is this first part right here. So I can see that from 0 to here, that was 60%. That would be baseball. Then hockey is this piece right here. So from 60, this line looks like it's about at 70. So this is not 70%. It's the percent between these two. So 70 minus 60 would be 10. So this piece right here is going to be 10%. And then just to finish it up, I know from 70 to 100 is what's left for football. So 70 minus 100 is 30. So this piece right here is 30%. So the question is, what percent is hockey? That would be that middle piece right there, so 10%. 26. Which question below would yield data with variability? So variability means I'm going to get a variety of answers, not just one set of answers. So A, how many 6th graders went to see a movie last weekend? So think about how you would answer that. There's really just a correct answer. 24 6th graders went to see a movie last weekend. Whereas B, what type of movies do you like to watch? You can see that there are going to be multiple set of answers for that. Maybe it's horror, maybe it's comedy, something like that. So B is going to give me variability. That's my answer. 27 says Jessie works part-time and earns $8 per hour. She earned $8 on Monday, $40 on Tuesday, $32 on Wednesday, $24 on Thursday, $16 on Friday, and $48 on Saturday. If her mean earnings for the week were $32, how much money did she earn on Sunday? So normally when we're finding the mean, what we do is we add up these numbers and then we divide by the quantity that we added. In this problem, we're missing one of the numbers, but we know that we want the average to be 32. So we kind of have the answer, and we're working our way backwards. So let's think about what's happening. Normally, I would add these up. So let's go ahead and add what we can. 8 plus 32 plus 24 plus 16 plus 48. And notice the $8 per hour I'm not including because that's not something she earned. That's just her rate. So this is the 8 I'm using because it was what she did on Monday. So 8 plus 2 is 10, plus 4 is 14, plus 6 is 20, plus 8 is 28. Here your 2. 2 plus 3 is 5, 6, 7, 8. 8 plus 4 is 12. All right, so normally I would take that 128 and I would divide it. All right, but what I have is a value that's missing. So I have 128 plus something. I'm going to call that x. Normally I would divide. There are, let's see, 1, 2, 3, 4, 5, 6 plus Sunday. So 7 numbers is what I would normally divide by. And I know that the answer should be 32. All right, I cannot divide this by 7 if I don't know what x is. So I'm going to work my way backwards. And when I can't divide, if I'm making this an equation, and I know this is a little different than equations we have done before, but you know enough about equations, I think, to do this. When I can't divide, what I do is I do the opposite. I solve by isolating, using an inverse operation. So the opposite of dividing is multiplying. So I need to multiply this side right here by 7. So if I multiply 32 times 7, 14, carry your 1, 21, I get 224. So I've multiplied by 7, multiplied by 7. Okay, so this part, the 7 part, goes away, and I still have the 128 plus x equal to, and I just made that 224. All right, so this is an equation of the type you've seen before. So if we cut this in half and try to isolate x, I'm going to do, again, the opposite of adding 128, which is subtracting 128. And that gives me, let's see, 6. Oh, I'm borrowing. I get, let's see. Is that 128? 160. Okay, I think I've done this wrong. Hang on a second. I did this wrong. I'm so sorry, guys. All right, so I left out one of the numbers. 8 plus 40 plus 32 plus 24 plus 16. Okay, so what I did is I forgot Tuesday. I'm so sorry. This is 8, 16, 168. So this should have been 168. All right, so when I subtract, that's 168 minus 168 minus 160. Okay, hang on. Let me just start over here. 224 minus 168. Then that's 14. This is 1. This is 11. So 11 minus 6 is 5, and 14 minus 8 is 6, so 56. So I get 56 here. All right, so my answer is 56. So she should have earned $56 on Sunday in order to have an average of 32. If I wanted to check my answer, what I would do is I would go back, and now that I have all 7 numbers, 8, 40, 32, 24, 16, and 48, and 56, I would add them up, divide by 7, and see that the average truly is $32. So sorry about that mistake, but, you know, I'm not perfect. All right, 28. The double box plot shows the average monthly high temperatures for Phoenix, Arizona, and Las Vegas, Nevada. Which of the following statements is not true? Las Vegas has the lowest average monthly high temperature. All right, so if I look at the graph over here, this one is for Las Vegas. Its low is 57 and Phoenix is 66, so that's true. It has the lowest average. B says the interquartile range of Las Vegas is, so that's from here to here, is greater than the interquartile range of Phoenix. So that would be here to here. So I need to find both of these. So for Las Vegas, I'm subtracting 96.5 minus 64.5. And that gives me 32. So for Phoenix, I'm subtracting 101 minus 72.5. So I have to give that one decimal, and I'm going to subtract. So 28 0.5. So it says that Las Vegas is greater, and that would be true. This is great. 32 is greater than 28. Okay? The median of Las Vegas is lower than the median of Phoenix. So the median of Las Vegas is 79.5, and the median of Phoenix is 86. So this is lower than this, so that is true. And D says the range of Las Vegas temperatures is less than the range of Phoenix temperatures. So the range is using the high and the lowest numbers. So that's a little different than IQR, which uses the Q3 and Q1. But I'm still subtracting. So 104 minus 57 would give me 47. And then for Phoenix, I'm going to use 106 minus 66. And that would be 40. So the range of Las Vegas is less than the range of Phoenix. And that is not true. It is more. So this one is not correct. So D is going to be my answer. It's not true. All right. And are we done? Yeah, we're done. So that completes the test review for Chapter 10. Remember, if you have any questions, come see me in the morning. I'd be happy to go over some more practice with you in the morning before your test. And hopefully everyone will do a great job. See you soon. Bye.